Hey, welcome. This is your LI AI. Today we are going to learn Ticketmaster system design in about 10 minutes. Interview ready? Now picture 10 a.m. on sale day, 500,000 fans hit buy for 20,000 seats. On Amazon, 100,000 toothbrushes means ship 100,000 toothbrushes. Here, the inventory is finite and the crowd is a motivated DDoS made of legitimate users. That's the vibe. The naive design sounds tidy. Auto scale booking, select seat for update, take payment. Sounds easy, right? So, what happens next? The whole interview falls apart. You cannot scale vertically out of a spike that's steep, and a 5-minute Postgres lock during checkout melts your connection pool before a single ticket sells. The database doesn't gracefully degrade, it just dies. Today's real problem is high concurrency contention. Protect the transaction engine with an edge waiting room, hold seats with short radius leases, and hard commit payment without double charge or lost tickets. Alright, let's lock requirements. Requirements: separate peacetime reads from wartime writes. If you mix those mentally, the design gets messy fast. Functional 1: search and browse events. Discovery stays fast even when a sale is hot. Functional 2: hold a seat with a TTL, then pay. Typically a few minutes to enter a card. Humans are slow, systems shouldn't pretend otherwise. Functional 3: never oversell. Two users cannot own seat 42, full stop. Below the line, dynamic pricing, ML, deep fraud graphs, multi-venue federation. Name them, park them, non-functionals survive a flash sale spike, hundreds of thousands of concurrent fans against tens of thousands of seats, controlled admit rate into booking. Read path must not touch the transactional database for seating charts under load. Consistency story holds our leases, sold is durable truth after payment. What you'd say: focus on waiting room, seat hold, and hard commit. Discovery cast, never oversell. And hold the line when the interviewer pokes discovery. Acknowledge search and seating charts, then return to contention. That is the loop they are hiring for. On consistency, say it cleanly. A hold is a lease that may expire. Sold after payment is durable truth. Do not promise linearizable availability for every fan at second zero of the sale. Correctness under scarcity beats fairness theater. Next, APEs and entities. APEs and entities. Make the hold explicit. If the hold isn't in the contract, the design isn't real yet. Search get event search with a query string. Hits come from Elasticsearch or OpenSearch, not Postgres full text under a sale. That's how you keep peacetime peaceful. Hold post holds with event ID and seat ID. Success returns hold ID and expires at say 5 minutes. Conflict 409: if the seat is already leased, that 409 is your friend. Use it. Checkout, post with hold ID and payment method. Returns order ID when sold. Internally, this is where outbox and idempotency keys live, not a naked stripe call on the web thread. Please don't do the naked stripe call. Entities, seat hold in Redis, key per event and seat, value user, TTL 300 seconds. Booking in Postgres, pending or sold with an idempotency key, inventory view, Redis bitmap or similar for availability, reads. Durable sold in SQL. The trap to say out loud, select for update for 5-minute human checkout. That is not locking a seat. That is locking your database to death. Next, back of envelope, scarcity math, back of envelope. This is where the room gets quiet in a good way. 500,000 fans, 20,000 seats. Most requests must lose gracefully. The system wins if it stays correct and alive, not if everyone checks out in 1 second. Instant fairness is a fantasy here. Admit rate trickle on the order of a few thousand users per minute into booking. Example 5000. So the transaction path has a bounded concurrency envelope. Autoscale cannot catch a vertical cliff at second 0. Cold starts lose. Tickets lose. Hold TTL. 300 seconds must live in a lease store, not a pinned SQL connection. Connection pools are counted in hundreds or low thousands, not 500,000. Do the math out loud. One more number for the room. If each checkout held a database connection for 300 seconds, even 2000 concurrent checkouts could exhaust a pool that looked fine in peacetime. That is why the hold cannot live as a SQL log. Leases in Redis keep the database for hard commits only. Say it, I size the herd versus seats before I draw stripe. Scarcity forces the waiting room. Hold duration forces Redis leases. Now high level design. High level design, peacetime and wartime. Two modes, one whiteboard, read path, event search mirrors into Elasticsearch. Seeding map, JSON lives on a CDN. Soft real-time availability can be a Redis bitmap the UI polls. Keep read storms off Postgres. Browsers can be busy without murdering your write path. Warpath. Fans hit an edge waiting room, API gateway, or edge workers with a distributed queue. The edge admits a controlled trickle to the booking API. Booking attempts Redis set with NX and expire on the seat key. OK means hold, nil means taken, clean. Checkout, write a pending booking plus outbox row in Postgres with an idempotency key. A worker publishes to Kafka, charges the processor with that key, marks sold, clears the Redis hold. If the worker crashes after a successful charge, retry is safe. The processor dedupes on the key. Boring retries. Love them. Walk it once as a story. Fan arrives, waits at the edge, gets admitted, selects seat 42, wins a Redis lease, enters card details, pending row lands, worker charges with an idempotency key, seat becomes sold, lease clears. If they abandon on the payment screen, the lease expires and 42 returns to the pool without a janitor job. Peacetime still matters in one sentence. Elasticsearch and CDN keep browsers busy, so wartime Postgres only sees holders who were admitted on purpose. Rename test, erase waiting room, set NX expire, and outbox, you are back to Amazon. Those boxes stay. Deep dive 1, the waiting room. Deep dive 1, virtual waiting room. Here's where it gets messy and where staff answers show up. Wrong. When asked how you handle 500,000 at 10 a.m., answer only with auto scaling, booking microservices. Cold starts and connection storms win. Tickets lose, the herd wins, you don't. Correct said load at the edge. Hold the herd in a lightweight queue, Redis sorted sets or edge queues, and drip users into booking at a rate the logs and database can mathematically survive. You trade instant access for correctness and uptime. That is staff load setting, not a product apology. Say the sentence, we cannot auto scale fast enough for a vertical spike, so we intentionally bound admit rate. Implementation sketch you can defend. Edge workers stamp tickets into a sorted set by join time and a releaser pops at the target admit rate. Clients see a waiting room page with position. Product honesty, while booking never sees the raw herd. If the interviewer asks about bots, say admission tokens that are hard to forge, then return to the architecture. Tokens do not replace the queue, they keep the queue honest. Next, seat hold and payment. The bar raiser zone. Deep dive 2, hold and hard commit. Lean in for this one. Wrong, select seat for update and keep the raw locked while a human types a credit card for 5 minutes. Under a flash sale, you exhaust connections in seconds. The pool doesn't complain politely. It just collapses. Correct hold. Red is set event seat to user with NX and expire 300. Atomic. Abandon checkout and the TTL freeze the seat. No cleanup cron required for the common case. Elegant. Wrong pay. Call Stripe on the request thread, then hope you write sold before the process dies. User charged, no ticket, or double charge on retry. Absolute nightmare. Customer support tickets as far as the eye can see. Correct pay, pending row plus outbox. Idempotency key on the charge. Worker completes sold and deletes the Redis hold. Retries are boring. Boring is correct. Bar raiser line, stripe succeeds, process dies before sold. Without outbox and idempotency, you either lose the ticket or double charge on retry. With them, replay is safe and the seat ends sold exactly once from the customer's point of view. That sentence is often the difference between senior and staff on this prompt. Quick practice beat, then we close. Practice this contention loop on your Ally AI at YourAlly.live. Written boards live on your Ally Academy under Design Ticketmaster. Alright, closing checklist. Recap. Summarize like you're closing the whiteboard with a marker still in your hand. Not Amazon, Edge waiting room, bounce admit. Read is set with NX and expire hold seats. Outbox plus idempotent charge, hard commit sold. Reads stay on CDN, search index and Redis bitmaps. Off the transactional database. 3 probes. Auto scale myth, waiting room, 5-minute SQL lock, Redis lease, charge then crash, outbox and idempotency. Mental checklist, scarcity framing, edge admit, Redis set NX expire, outbox plus idempotent pay, reads off the right database, redraw the HLD once called tonight. If waiting room, lease and outbox still appear, you are ready for the room. Academy, YourAlly.live/academy/system design/design Ticketmaster. Practice until the answers feel automatic. Your Ally AI at YourAlly.live. Rehearse until calm. Thanks for watching. Go redraw it cold.